Hello. I will tell you about the management of job streams. That is transaction workflow actually, but I do not like English names, that's why let me speak Russian. At first, I would like to tell you an anecdote from the life of my colleagues. It happened 2 years ago. We worked in a big telecom company. This company decided to wish happy birthday to its customers by sending short messages to them. It seemed not to be a big problem. And one day, one man in Honduras or in Salvador received 50,000 messages with happy birthday. The problem is that this man had a very old phone, and when it had a lot of messages, it had to restart. So this man had to phone the company and ask them to stop sending him messages. These messages did not cost a lot of money to the company. But the customer was upset, and if we managed that this was not about messages but about payments, then the damage for the company would have been much higher. So, when people start speaking about damage compensation, they normally become more careful. So, that's why during my presentation, let's imagine that we're speaking about money payments. So, what was the problem? Why did it happen? The problem was that transactions were not processed properly, and the flow was not set up. What is transaction flow? This is about a lot of transactions that are to be conducted by a specific way. So if one transaction finished successfully, you can conduct another transaction or another job and so on. And in Postgres Pro Enterprise, I have two favorite modules. I'm going to speak about the second one, scheduler. It can conduct these things. On the one hand, it seems quite trivial, but on the other one, it's really important for me when I conduct some complicated backup processes in backend. These things are really useful to you. So there's an interesting feature. They may be conducted for a very long time. I'm not speaking about a part of a code, but time between the steps. It can take minutes, hours, days, maybe even months. Maybe not a month, but in my experience, this process took 1 week. It's clear that we cannot use one stream here, one flow here, because it will consume memory and resources for several days. And what will we do if we have to stop it? And they can be lost. If we lose a happy birthday message, no one will notice that. But if we lose payment, customer will call us and write us and complain to us. And you know, normally when the amount of money is really small, customers complain a lot. We cannot conduct payment more than once. Understand that if our customer receives some additional payment, they will not be upset. If it happens once, it's okay, but if it happens several times, company may lose money, because it's normally quite difficult to get money back from the customer. And and it's quite expensive to address the court. So we should try and send the payment only once. It's not only about money. For example, there was a service, a company that sold cars, provided auto loans. So when the company requested a server to provide some data, they had to pay money. That's why this company should send only one query regarding one piece of data. Because if we send 1,000 rubles to 100 customers, the company will incur some losses. That's why we are to be quite careful here. And also we should follow the schedule of transactions. In case of messages, that's not really important because there was a single message there. But in case of complicated business processes, we need to have a special sequence. For example, now we cannot give a mark to a student before enrolling the student in a group. So at first the student is enrolled in the group and after that they can receive a mark. How can we do it? We can do it through transaction warehouse. That's about DBMS and queues. We're going to speak queues as well. And I think that in this case, database management system is the best choice. So we're going to speak about Postgres. What can we say about single jobs? They are created for single execution. Shadow makes it possible to conduct jobs periodically, by schedule, every hour, and so on. But this is a single job. So they were executed and finished only once. Numerous of them can be executed. If it's a cron's job, well, sometimes its execution started, but the previous job has not finished yet. And these jobs may be conducted in parallel, and they may be numerous. A job may be either executed successfully or not. If it was not executed, then there should be a record that says that a failure had occurred. I wouldn't like to have this data in a table because it's quite easy to open a document and check it. And I don't think that you really need to get this information. You can do it if you are interested. Besides, in a number of cases, jobs may require repeated execution. And later we will speak about Bitcoin's transaction. I'll show you where these things might be necessary. And they may be strictly arranged. Because, as I mentioned, sometimes the sequence of execution is really necessary. Sometimes it is not important. Normally, different groups of jobs can be executed in parallel. So for one user there is one stream, and for the other user there is another stream. But sometimes we need a sequence. I can give you a case from my experience. Our customer had to update their price list in their business units. So how could they do it? Some updates are related to all the business units. Others are related to some specific business units, so there was some logic here. These updates should follow in a sequence. So if we have one price in the morning and another price in the evening, it's not okay. We should not mix this up. Besides, there was the issue of connecting new business units. Price list was not big there, about 20 to 30,000 items. So, if one business unit is not available because of some reasons, we are to show what reasons, what business units coped with this task and what did not do it. I do not think that they will manage to change everything in all 800 business units, because some of them will fail to work. And what are the options, possible solutions? Logical replication. So we can do 800 tables for every business unit, add new ones if necessary, and give them these tables. It will be quite okay, but it won't be really convenient. Besides, there is a connection with a server, and there are 800 connections to a server. Alexei, do you think that 800 connections to a server is okay? Alexei says that it's really impressive. Well, of course, normally there are several way outs from any situation, but I do not think that this way out is the best one. There is another option. A side queue. Well, yes, it will work, but here the sequence of message delivery is not guaranteed. So in case of failure, it will not work. What do I mean by the word failure? Do you know what a poison message is? Well, unfortunately, no one does. Imagine we have a line of messages, they follow each other, and we have a message in this sequence that cannot be processed. In that case, all messages are not processed. The system of message processing can do it, and if we receive such a poison and the system did not manage to process it for several times, this message is put aside and the work is continued. So, updates for one service may come in a wrong sequence, and in that case one message will be lost. That's why we should stop it and find out why it doesn't work. Normally there are no problems with single jobs. Let's see what we have. So we had 160,000 jobs a day. That's not many. Processing is quite simple. We get a job, we follow the protocol, and use some simple scheduler. Well, yes, we will have to create code, but I think that replication setting will require more efforts compared to this thing. Moreover, how can we provide for a sequence of message execution? We have one message and after that another one, specific sequence. For example, when a job is executed, within one transaction, a new job is created. And it goes like that. Well, it's good, but it's not flexible because we should know what job we need to create next. And besides, it's not really convenient when we speak about connection of a new business unit. If these messages do not depend on each other, we can just read all the items in price list and make messages containing a comment to add. If we know how transaction model works in Postgres, then we will see the snapshot. We see no changes, we see only the current situation and add. After that, all changes will be added to the ones that were previously created. So messages should be determined by external environment, and Shader has it. Another case related to blockchain. This topic is quite relevant. You know that Bitcoin is falling now. Have you ever worked with Bitcoins or with blockchain? One person only. But still, we have such people here. Oh, you created your own currency. Okay, now I'm going to speak about blockchain. This is the sequence of blocks that consist of transactions. Bitcoin is quite complicated. Every transaction is a group of addresses in the input and output. And these addresses in input are divided into the addresses by the addresses in the output. So it's similar to a message when money is sent. Unfortunately, in Bitcoin and almost in all blockchains, transactions sending is not really appropriate. I'm going to explain you what the problem is here. In Bitcoin, there is such a notion as wallet, that is a set of addresses with amounts that we can use for sending money. And in order to use the wallet to send specific amount to a specific address, to a specific account actually, we specify the address, the amount, the comment, and that's it. Can you see any problem here? And do you remember the situation with these short messages? Confirmation. We send it and we have a timeout. So the question is, have we sent it or not? And can we repeat this transaction? In the case with the message, we decided that it was possible, but if we speak about bitcoins, well, it's about money. And the system is automatic. We can send many thousands of times and lose money. So who will pay for it? Yes, if someone comes to my masterclass tomorrow, I will speak about this in details. Actually, there is an option to assemble the incoming address, create transaction, and try sending it. And in that case, you will get a message in case transaction is not successful. Unfortunately, in that case, you will have to monitor the state of all the addresses, so it's not really convenient. Here we have another problem. How can we send it so that we won't send it repeatedly several times? It's not only about Bitcoin. Actually, I worked with many payment services that used Russian rubles, and the mechanism was quite similar to the one of Bitcoin. It's quite sad, but still, we had to deal with it because the business needed them. Here I have a pseudocode on the screen. Can anyone tell me where the mistake is? Excuse me. That's right. So what? So it doesn't seem to be complicated. You send it and you input paid here. Well, of course, there are side effects here. Yes, there's a problem here. This option looks okay, but it's not appropriate. Why? Because messages have been sent for many years and there were no problems. So, only when this man with an old phone who failed to receive messages triggered actually the manifestation of this problem. So we should not think that all mistakes occurred due to external things. Sometimes mistake are the fault of the person themselves. So if we have a specific procedure, we should be ready that specialists will not work with that the way they should. If we call another function, we should be ready that something may go wrong, even if it was you who wrote this function. And we need to remember that it's better to refrain from doing the operation than doing it wrong. You can look here. At first, we put state pane where this state is ready. In the first case, we could pay for two streams twice, but here it's not possible, so we have either paid or not. So the first transaction for payment was conducted, the payment was transferred, and we receive the message, paid. And what is wrong? What else? Well, it's bad as well, but at least we won't pay twice. Have you thought about this? So we can get a failure due to the network, due to power problems or hardware problems, anything. And either payment will not be conducted or, well, in a number of cases, of course, we have payout. So no confirmation came. In that case, we are to deal with it manually, but sometimes we understand what is going on. And 20% of errors go to servers. 80% of mistakes are other type of mistakes. Here is the stream that we have. At first, transactions should be executed. So in one transaction, we write that it's being paid, and if everything's okay, then we have the following job for execution: to conduct payment. And if it worked, then we should put the state paid. So, unfortunately, the text on the slide doesn't look nice. And here is the job stream that we have. Speaking about our schedule, it's quite simple here, and I like it. Has anyone worked with DMS schedulers from Oracle, and do you like it? It can do similar things. I have always thought that it's quite heavy, too heavy, so it can be actually a bit easier. Of course, I understand that it might be useful, but still I would like this process to be simpler. Postgres has one function. In this regard, it has a lot of parameters, and here I would like to specify that we have a query that can receive the parameters like $1 and $2 and two more values. This is timestamp and depends on. These are all jobs that were created before. It means that this job is to be executed only after the previous ones finish successfully. If they failed, then everything stops. As I mentioned, we have a send-to address, ID transaction, and it's not really convenient. Sending to blockchain. On a masterclass, I will show you Bitcoin sending to blockchain from Postgres. What happens when we want to send transaction to blockchain? Normally, transaction is not submitted to blockchain. It gets into mempool. Miners get transaction from the mempool and try to assemble it into a block. Bitcoin ID may fall without transferring this transaction any further. And we want everything to run smoothly. That's why we should be careful. So transaction gets into main pool, and after that it will get into blockchain. It can stay there for quite a long time, for several days even. It can even stay there forever. I haven't seen it actually, but it's possible. But quite often it can stay there for several hours, especially now when the cost is falling. So what do? We send it, get transaction ID, and start reading blockchain, waiting when we get this transaction. In blockchain, there is a notion of fork. It means that blockchain is divided into several branches. The longest of them survive, others die. Our transaction may get into the branch that is dying, so we must be sure that it is located in quite a deep layer. So 1 or 2 blocks is quite possible. Normally, confirmation of 1 block is sufficient, for small amounts at least. So at least there should be 1 confirmation, but it's better to have 2 of them. Or it can depend on the amount. For small one, we want to get 1 confirmation, and for big amounts we want to have 2 or more confirmations. So we send a transaction, we processed all the arrows, we received ID, and we start waiting till this transaction appears on the necessary depth, and if it did, we consider the job fulfilled. And if we cannot see transaction in meaningful or in blockchain, in that case we are to conduct this process once again. And what shall we do in case of an error? If we failed, for example, maybe we do not have the necessary funds. We have half of Bitcoin, but we want to send 0.6 Bitcoin. What can we do in that case? Well, we should write that we do not have money. It's quite an important issue. We write it to monitoring, and we still try sending this amount. Because after they send the money, we will manage to do it. Or maybe we receive such an error as connect timeout or connection refused. Actually, this error is to be processed. In that case, the administrator will manage to redo something. So we are to be really attentive to process this mistake. There is another type of error when we need to stop processing. For example, if we received no response. If there is a high load on your machine, for example, you send transaction and you have not received any response for 10 minutes. So here there is a question whether it was sent or not. We can read blockchain and check whether this amount was sent to this address, but anyway, that's a specific process. We can delegate it to the administrator. So errors can be divided into the ones that cannot be rectified and the ones that can be executed. And the second type of errors includes the error when we don't have money. Here you can see the scheme of sending. I wanted the scheme to be a bit different. Like, do you know what McQueen annotation is? So in that case I will have to tell you what it is. That's why I decided to draw a block scheme for you. Payment block. It's important in order not to send the payment twice. If it was sent successfully, we wait for confirmation. We received a confirmation. We go backwards and we input a log here, log payment. If we failed to pay, we are to find the reason why it happened. So this operation is quite simple. Send this amount to this address. It's not only about blockchain. And I think that most services that work with data modification are based on similar blockchain. Add a user, it's okay. And when we edit it and return, there is only one user. Who has ever written such services? And what should you do in case of timeout? Add a user and no response. Well, that's a specific question, how to fight such things at the level of services. Well, I would like to say a few more words. I'm not going to read you the documents regarding the functions. So it's possible to add a single job, and it's possible to get your own identifier. You can start the process of repeated sending, and I will call this function submit, resubmit after. You can deactivate it, you can stop it and delete it. And why do you need to stop it? For example, when we need to have a form for an operator, they have to do something and they put a tick approved. And this process goes on after that. Why PG Pro scheduler? Why can't we take another one? Well, actually, there are quite a lot of such things on the one hand, but on the other hand, somehow they're not popular. I don't really know why. We have some web frameworks, quite a lot of them, and why don't we have frameworks for background, for back office? But still, they are not very popular. We have Oracle Scheduler. It is good, but it is too complicated, I think. And there is Oracle. If you want to use it, you need to have Oracle. It's quite reliable, but it's rather complicated. In SQL Server, there are jobs. I have not worked with them. I think that they're quite okay. Besides Oracle and SQL Server, have quite a good GUI. It can also be quite important sometimes. Speaking about BPMN, that is Business Process Management Notation, well, as far as I can see, no one has worked with them. Actually, this notation describes these jobs. It's quite good, it's rich. And unfortunately, this process is described as a scheme. It's quite okay for simple jobs, but it's not good for complex ones. If you're interested in it, you can look at these block schemes and see how you can work with exceptions. It's possible to do it as well. This thing is quite flexible and powerful, but it has its own limitations. Do you like Java? And I think that others do not like Java. Actually, Java and C# are used there on these options. If you use Python or Perl, you will have no options here. So you have to devise something yourselves. And these are pictures. So there are problems with Git. How can you see the changes, for example? Actually, design means enable you to see what was changed. But their operation is not stable. Patch cable is another option. Actually, I would like to take it. Do you know what patch cable is? It's a great thing, but you have to get used to it, and you have to understand what it is. But it is very convenient, and I really recommend you to use it. And there is Spring Batch. It will work, but it's quite complicated. And and you got to get used to it as well. There is another option with batch, that is Java Enterprise Edition. It's quite sophisticated, but it will work. They are quite reasonable, actually. Batch cable is Java Spring, and there are two options here. We can use XML or notations here. It depends on you. If you like Spring Batch, you can use XML. These are very sophisticated things. There's another thing, Celery. It reminds Camel for Python. Has anyone used it? Did you like it? You know, I didn't like it. Why didn't? Because there are no transactions here. So you cannot send money. Besides, on big loads, its performance is quite low. So performance and transactions, GPBM, despite its sophistication, is quite quick, although it's heavy. Has anyone worked with German? No? German, it's a service written on C. It is quite good. There is no arrangement there. It is not transactional, so you might have problems, and you shouldn't use it for sending money. And, I don't know, maybe I forgot to mention something. If I did, please tell me about it. Actually, there are a lot of options there. Lots of workflows. But they're not popular. So we don't have many options when we want to send transaction. We should use Java, Oracle, or Postgres. Or you can write it yourself. It's not really complicated, but you will have to spend about half a year for it. So that's it. Do you have any questions? Do you have any questions? Yes. Hello, Alexander Pankratov from Paros. So this utility, Chedula dot, I've seen it on the picture. This function, is this function from PGSQL? So I can call this function from PGSQL, and it will create a parallel process by schedule that will start by schedule. No, here I show the ones that will not be launched by schedule. It is launched once. No, but there is such an opportunity without inputting schedule. Oracle has such an opportunity, yes. It has an analog that makes it possible to launch this process by schedule. And in Oracle, for a task to start, you are to conduct commit. Yes, here it's similar. And we can do commit on the client only, or we are to create DB link and call it there. Well, actually, here, commit is to be used. No, what I'm asking about, in Postgres, we cannot write commit function. We are to return to the customer, but in Oracle we can do it, but it's bad. Well, that's quite a controversial issue, but commits should be present here by all means, yes. But theoretically, I can do DB link, and, well, you can. But here the idea is that we do something, and after it was executed, we launch the job. So if we failed and we start a new job, it's no good. And the last question, it's in Postgres Enterprise, right? Yes, 9.6 and 10. Yes, 9.6 is present already. Yes. Thank you for your presentation. I have two questions. The one is related to the architecture. So if you tell me to look in the code, I won't be offended. If current place is quite complicated, then the operation give me the job that can be executed may be quite expensive. How is it arranged? Yes, it can be expensive, but it's bad when we have very long chains, several thousands, for example. In that case, yes, but normally typical jobs are quite short. For example, if you look at blockchain, here we have 1, 2, 3, 4, 5. Yes, I agree, thank you. And the second question is about the parallel nature. I know that there is a pool of workers that fulfill these jobs. Can there be any control of parallel nature, for example, to mark this job as red, blue, and say, no, now we can't do it? In the example that you've shown, PG schedule, what is the type? This one, yes. So query, it's just a query, the text of the query. Stored function and access to operation system can be conducted from it on the level of SQL. Well, actually, if you do not have any additional modules, then no. So roughly speaking, if I want to start doing it, then I'm limited by SQL query. Yes, look here. I don't know whether you will be present in my masterclass or not. I will use a third-party server and I will call it. Here it is. Victor Stomin. How can it be monitored? So can you monitor the jobs that are executed and the jobs that are not executed? Yes, we can. There are special tables where you can see the jobs that have been executed, the way they have been executed and that are being executed now. And what about logging? Well, there is a log there, but actually I want this to be more detailed. Thank you. Do you have any other questions? That's it? Okay. Thank you. Thank you for your presentation.